Okay, now let's continue with our fourth lecture in this series, and I'm now going to start on diffusion. So you know what the range of neutron energies is. In the last uh, lecture, I said that it goes down from about 0.025 electron volts to MeV. So from a neutron source, the neutrons are born at very high energies, such as californium 252 produces a spectrum of neutrons. So we don't have slow energy sources in the world, we've got fast energy sources. Now, the only place where you can get a thermal uh, source of neutrons would be a nuclear reactor. So now this is what basically a neutron does. It is born at some high energy. It undergoes collisions with atoms of the material it's passing through. For example, in air, neutrons would collide with oxygen, nitrogen; in water with hydrogen, oxygen; in steel with iron, carbon, nickel, manganese, etc. And they would gradually lose their energy. They would slow down and they would thermalize. So broadly speaking, there will be fast neutrons and thermal neutrons. So neutron transport is the story of a neutron slowing down from a fast neutron down to coming into thermal equilibrium with its surroundings and ultimately being either absorbed or leaking out of the boundaries of the system that you're talking about. So this is the life of a neutron, from source to absorption. And whenever we talk about its transport, we have to model all these in our formulations. There's something called a neutron cross-section. Now that is a probability. The word cross-section means that if you look at it from straight, like you look at a football, it looks like a circle. So cross-section means what is the area that a neutron sees an atom. If it's a big area, that means there's a high chance of colliding with that. So cross-section has units of barn. Now barn is a very small area. It's 10 to the minus 24 centimeters square. The word barn was given in Manhattan Project. It was because Manhattan Project was a nuclear weapons program, so they were all classified research projects going on there. So they gave it the name barn. Now neutrons undergo many possible reactions. They can scatter, they can be absorbed, they can raise the excited level of a nucleus, take it to a higher level, then it falls down to the ground level, it emits a gamma ray. So basically it can elastically scatter like a billiard ball collision, it can inelastically scatter, it can have an alpha reaction, which means it could disappear and produce an alpha particle. It can produce a gamma. So a neutron can go into a nucleus, disappear, and you will see an electromagnetic gamma radiation coming with the difference of energy between the incoming neutron and the energy absorbed by the nucleus. So in the next fifth lecture, I'm going to start with neutron diffusion.